Welcome to today's Explainer. Listen, if you're studying for the Cambridge Mathematics exams, whether you're tackling the 0580, the 0606, or the 4024 syllabus, you already know what you're up against. The margin between an average grade and a top-tier, absolutely flawless result, it almost always comes down to execution. It comes down to precision. When an examiner pushes you out of your comfort zone with a complex, multi-layered question, you don't panic. You push back. And you push back with perfect answers. Today, we are focusing entirely on your most critical exam partner, the one tool sitting on your desk that can make or break those final answers, the Graphic Display Calculator, or GDC. Now, this isn't just a basic tutorial about figuring out where the on button is. No way. This is about absolute mastery. It's about turning this device into an extension of your own mind so you never, ever lose a single solitary mark to clumsy navigation or those devastating rounding errors. By the end of this, we're going to completely transform the way you look at that device in your hands.
Okay, let's dive into this. Have you ever actually stopped for a second, looked at that incredibly powerful piece of technology sitting there, and wondered about its ancestry? I mean, we completely take for granted that we can punch in a complex polynomial function and instantly see its graph plotted perfectly on a digital screen. But the human drive to calculate, to solve intricate problems, and to measure our physical world, that's ancient. That is baked into our DNA. The journey from literally pushing wooden beads on metal wires to executing advanced digital algorithms, it's just a fascinating evolutionary leap in human problem-solving capabilities. It really puts things into perspective before we get into the tactical stuff. So, here is our roadmap for today's session. First, we'll quickly look at the evolution of calculation. Second, we'll meet the modern GDC. Third, we are going deep into navigating your dashboard. And finally, Section 4, the absolute game changer, mastering memory channels. Let's start right at the beginning. Section 1, the evolution of calculation. It is genuinely crucial to realize that your modern GDC is the culmination of thousands of years of human ingenuity. Think about it. We have always built tools to overcome the limits of our own biological processing power. Just look at this historical timeline we've mapped out here. Between 2300 BC and 500 BC, the abacus was invented. This was the absolute workhorse for addition and subtraction, and incredibly, it's still widely used in certain parts of the world today because it's just that efficient. Fast forward quite a bit to 1621, and the slide rule enters the scene. This enabled significantly more complex operations and was the go-to tool for engineers right up until the 1970s. Then, in 1642, a mathematician named Blaise Pascal introduced the first mechanical calculator, which utilized a wildly complex system of physical gears. But the real shift, the moment everything changed, that was 1967. That is when the first handheld calculator appeared, entirely made possible by the development of the integrated circuit. Now, what's really interesting to consider here is that these historical tools were, in essence, the graphic display calculators of their specific eras. The abacus provided a tangible, physical spatial representation of numbers. You could see the math. The slide rule, it literally used physical distance on a logarithmic scale to perform complex multiplication and division. They were tactile, visual representations of mathematical truths. They were doing exactly what your modern digital screen does today, just doing it without the glowing pixels. All right, moving on to Section 2, meet the modern GDC. We are officially leaving the history books behind and stepping right into the high-stakes environment of the modern mathematics classroom. Here they are, the two absolute heavyweights of the Cambridge syllabus. On one side, we have the Casio FX-CG50, and on the other, the Texas Instruments TI-84 Plus CET. Take a quick second to identify which device you are currently holding or which one you are planning to use for your exams. While many graphic display calculators essentially share similar underlying computational capabilities, the button layouts, the menu systems, and the specific syntax you have to use, they vary significantly between these two. Knowing the general theory of a math concept is great, but you need deep, reflexive muscle memory on your specific device. Before we continue breaking down exactly how to master these devices, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Because here is the hard, unavoidable truth straight from our source material today. As with all tools, their effectiveness is only apparent when used properly. Listen to me carefully here. Simply owning a top-of-the-line Casio or a Texas Instruments calculator absolutely does not guarantee you a top grade. It just doesn't. Think of it like a high-performance Formula One race car.
That car will not win a single race if the driver sitting in the cockpit doesn't know exactly when to shift gears or how to handle the corners. You must actively explore its capabilities, understand its quirks, and push it to its limits to unlock its true potential on exam day. That brings us to Section 3, Deciphering the Dashboard. To help you become that expert driver we just talked about, let's decipher your command center. We're shifting away from the hardware and getting right into the software. What you are looking at is the main menu for the Casio. As you can see, it's a highly visual, totally icon-based experience. Instead of scrolling endlessly through dense, text-heavy menus, you have these distinct color-coded squares. You can select these modes either by using the physical directional arrow keys and pressing the Execute button, or, and this is for maximum speed during a timed exam, by simply typing the specific number or letter shown right there in the top right-hand corner of each icon. It's a massive time saver once you memorize them. Let's methodically break down these core modes right now, because knowing instantly which one to jump into solves half the battle. Mode 1 is Run Matrix. This is basically your home base for all standard arithmetic calculations, which you type directly onto the screen. Mode 2 is Statistics. You'll jump here for entering datasets and generating statistical graphs. Mode 5 is Graph, completely dedicated to entering the specific equations of graphs and plotting them out visually so you can trace intersections and roots. Mode 7 is Table. This mode is brilliant. It generates a neat list of numerical results derived directly from an equation you provide. And finally, Mode A, sitting right at the bottom, is Equation, which is your go-to for efficiently solving various different types of complex algebraic equations. Now, to physically interact with these menus on the Casio, these are going to be your most frequent touchpoints. On the one side, the EXE or Execute button. This is your confirmation key. It selects your mode or calculates your final result. And on the other side, the large silver directional pad. I cannot stress this enough. Under the immense pressure of exam conditions, your thumb should know exactly where these physical keys are without you ever having to look away from your test paper. And speaking of not looking away, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, we certainly haven't forgotten about the Texas Instruments users. For the TI crowd, your interface relies slightly more on dedicated physical buttons rather than that central icon-based menu we just saw on the Casio. For example, here we see the Stat button, which is your absolute gateway to list management and all statistical calculations. Right next to it is the Y equals button, which is step number 1 for entering functions anytime you need to plot out graphs. While the pathway to get to the answer looks different from the Casio, the final destination and the raw mathematical power in your hands are exactly the same. All right, it is time for Section 4, Mastering Memory Channels. Let's get into the advanced tactics. Listen, if you take away only one single technique from this entire explainer today, let it be this. The source material states it incredibly clearly, and it is the absolute golden rule of Cambridge mathematics. Use memory channels to store answers for subsequent calculations. This will minimize rounding errors. Early rounding is the silent killer of exam grades. It is the enemy of accuracy. In complex multi-step problems, if you calculate an intermediate answer, round it off to, say, 3 significant figures, and then plug that rounded number into your next step, your final answer will be skewed. It will drift away from the true value. And in strict Cambridge mark schemes, that skewed final answer is marked wrong. Even if your mathematical logic was 100% flawless, you lose the mark because of poor execution. Let's actually look at a side-by-side comparison to see why this happens. On the left, we have the flawed way. This is where a student gets a long, messy decimal like 3.14159, scribbles it down on their scratch paper as 3.14, hits clear on their screen, and then manually retypes 3.14 for the next step of the equation. You have just introduced a massive inaccuracy into your work. Now look at the right, the smart way. This is keeping that unbroken, pristine string of perfect, unrounded decimal data stored directly inside the calculator's digital processor as a specific variable, like memory A, B, or C. Then you simply call upon that exact perfect value when you need it later. No typing, no rounding, no lost marks. The actual mechanics of executing this on your device are incredibly simple once you get the hang of it. On a Casio calculator, you'll perform your initial calculation, hit execute, then press the little arrow symbol button, which literally means store, and then immediately press a red alphabetical key like A or B. Boom, it's saved. For Texas Instruments users, there is a dedicated button labeled STO that serves the exact same purpose. You hit STO, pick a letter, and enter. You are essentially taking a perfect infinite numerical value and safely locking it away inside a letter for later use. Let's walk through an actual exercise from the textbook to see this exact workflow in action. Imagine a problem that presents 4 different circles. Let's call them A, B, C, and D. They have varying radii of 10 centimeters, 6 centimeters, 4 centimeters, and 1 centimeter. The ultimate goal of the question is to find the total combined value of area A plus area B plus 2 times area C plus 2 times area D. Now, instead of calculating all these individual areas, writing down incredibly messy, pi-heavy decimals on paper, and then trying to add them all up, we do it the John Wick way. We calculate the area of circle A, which is pi times 10 squared. The screen fills with numbers. We don't write a single thing down. We immediately store that perfect value into memory channel A. Then we repeat this exact process, calculating and silently storing the perfect, unrounded areas into channels B, C, and D respectively. And this brilliantly illustrates how you seamlessly combine your basic operational buttons with these advanced memory functions. You are going to be using this x squared button heavily during those rapid intermediate steps. You're squaring the radius of 10, you're squaring the radius of 6, you're calculating that raw area, and then critically executing that store command before you ever let your finger hover over the clear button. It becomes a rhythm. Calculate, store, clear. Calculate, store, clear. Okay. Let's elevate this. Let's look at a genuinely complex, multi-step, real-world application directly from the source material. This is the kind of question that separates the top tier from the rest. Imagine 3 solid balls, each one possessing a 5-centimeter radius. They are perfectly fitting inside a cylindrical tube, stacked tightly right on top of one another. The question asks us to find the total volume of the cylinder that is not occupied by the balls, the empty space. Now, this requires juggling multiple formulas, executing multiple intermediate steps, and absolutely zero room for rounding errors. The very first logical step is isolating the volume of just a single ball. We pull up the standard formula for the volume of a sphere. V equals 4/3 times pi times the radius cubed. We plug in our 5-centimeter radius. You hit execute, and the screen outputs a very long irrational decimal number. Do not write it down. Resist the urge. Instead, while that pristine number is still on the screen, immediately store that precise answer straight into your calculator's memory. Let's lock it into memory V. Now we move in for the final step. We need to calculate the entire volume of the surrounding cylinder. Since we know the balls have a 5-centimeter radius, their total diameter is 10 centimeters. 3 10-centimeter balls stacked perfectly on top of each other means our cylinder has a total height of 30 centimeters, and it shares that same radius of 5 centimeters. We quickly calculate the cylinder's volume using the formula pi times radius squared times height. Once we have that massive total volume calculated on the screen, we simply type -3 times memory V. By calling upon that unbroken, unrounded spherical volume we cleverly stored earlier, we arrive at the final unoccupied space with absolute, perfect, zero-error precision. The examiner literally cannot find a single flaw to deduct a mark for. Which leaves us with one final critical thought. You now understand the history of these devices, you've deciphered the dashboard, and you know the absolute secret weapon that is memory channels. So the choice is yours. Are you still going to risk losing those hard-earned marks to manual, clumsy rounding errors, or are you ready to finally let your graphic display calculator's memory channels do the heavy lifting for you? The tool is right there in your hands. Now it's up to you to execute flawlessly. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.